Hard. A linear function f satisfies f at 0 is equal to 7, f at 1 is equal to 11, f at 2 is equal to 15. If h of x is equal to f of x minus 5, which equation represents h of x? Okay, let's go review everything that they're giving us, all the key information. All of these represent points that we can plot, okay? And h of x is equal to f of x minus 5. So we know that to find h of x, we need to understand what is f of x. So let's break that down a little bit. If this is our graph, x and y-axis, this says f at 0 is equal to 7. So f at 0 is equal to 7 means that when x is equal to 0, that's what we plug in, our y value is 7, or 0, 7. F at 1 is equal to 11 means when x is equal to 1, our y value is 11, so 1, 11. F at 2 is equal to 15 means when x is equal to 2, our y value is 15. Our point is 2, 15. So when we graph this, at 0 and 7, at 1 and 11, at 2 and 15. So our line would look something like this. Oops. I need to draw it as straight as I can. That is what f of x is, right? When they're saying a linear function satisfies these, we're saying that our f of x will pass through every single one of these points, the one we listed here, okay? Which means if it passes through them, we can create a line, and now we can come up with a linear equation to represent what this line looks like. So recall that a linear equation is y is equal to mx plus b. What do we need to solve? Well, we need to know what m is, and we need to know what b is. B is the y-intercept, and m is the slope. How do we figure these out? Well, the slope is y2 minus y1 over x2 minus x1, which means we can choose 2 points, these two or these two. It doesn't really matter. Just choose 2 points and solve. I'm going to choose these two. I'm going to label them as well as y2, y1, x2, x1. So then we get 15 minus 11 over 2 minus 1 is equal to 4 over 1, or just 4. That is our slope. The rate of change is 4. The y-intercept just means where does this line, right, pass through the y-axis? Well, we see that it happens right here, and we plotted that. What point was that? Well, that was 0, 7. So our b value is 7. So we can come up with an equation to represent f of x to be 4x plus 7. Okay? Remember that this is just equal to f of x. Okay, now what? Well, we still need to figure out what h of x is. And they told us that h of x looks like this, right? So then h of x is equal to 4x plus 7 minus 5. This is from here. We plug in f of x because that's what they tell us to do. So we now subtract 5 from that. 4x plus 7 minus 5 is plus 2. Therefore, h of x is equal to 4x plus 2. A. The function c of x is equal to x minus 273.15 times 9 over 5 plus 32 converts temperature from Kelvin to Fahrenheit. If the temperature increased by 10 Kelvin degrees, how much did it increase in Fahrenheit? Okay, so first let's analyze this equation. This could have just easily have been written as f at k is equal to k minus 273.15 times 9 over 5 plus 32. Because we're saying that this equation converts from Kelvin to Fahrenheit, which means that if we plug in Kelvin, the result would be in Fahrenheit. Okay? So the most basic approach to take here is actually just using an example. So we're saying, what if the Kelvin degrees was 300 and then it increased to 310, right? What's the difference in Fahrenheit? So we want to calculate what is this in Fahrenheit and then what is it in Fahrenheit here, and then see the difference of the two by how much did it increase in Fahrenheit. Okay, so let's do that. F at 300 is going to equal to 300 minus 273.15 times 9/5 plus 32. When you compute this, you should end up with 80.33 Fahrenheit. F at 310, right, now the 10-degree increase. So we're doing this to show, well, what happens when we add 10 degree in Kelvin? What happens in Fahrenheit? Is 310, so 310 plugged in minus 273.15 times 9/5 plus 32. When you compute this, you should end up with 98.33 Fahrenheit. Okay, so now we're saying, okay, well, a 10 degree in Kelvin increase results in, well, 98.33 minus 80.33, which is equal to 18-degree change in Fahrenheit. So B. Okay. Another way you could think about this, and it's a little bit different, but it's just about focusing on the coefficient of x, right? So let's take our original equation. So C of x is equal to x minus 273.15 times 9/5 plus 32. Just to remind you that we're talking about, this is Kelvin, this is Fahrenheit, right? We're converting from Kelvin to Fahrenheit. So Kelvin is x. So if we're talking about a 10-degree increase, well, originally this is 9/5x minus 273.15 times 9/5, right? We're distributing this 9.5 to everything inside the bracket. This would be similar if you did like 4 times x minus 2, right? You would distribute, so 4x minus 8, same thing we did here, plus 32. So this is what's important, the coefficient. So we know that whenever we convert to Fahrenheit, we're going to be adding or subtracting some big number or some small number, whatever. And then also multiplying the Kelvin degrees by 9/5. You get 9/5x minus 459.67, okay? Now they're saying if Kelvin increased by 10, so our x value increased by 10, well, that just looks like C at x plus 10 is equal to 9/5x plus 10 minus 459.67. The reason we do this is to actually see the difference between the two equations. What changes, right? So in a small example, like if I said y is equal to 2x plus 4, and then now we say y is equal to 2x plus 10, right? What's the difference? Well, we're saying we're adding 6, right? We added 6. That's the same idea here. We're going to compare the two to see what the actual difference is. So we simplify this 9/5x plus 90/5 minus 459.67. And what we end up seeing is that all of these components are from the original equation, and the only thing different is this value here. Well, that's just 18. 90 divided by 5 is 18. So the difference is 18 degrees Fahrenheit. Right? That's what happens. That's how the output changes. So there's two approaches you could take, whichever one makes more sense to you. That's the one you should use. Okay. Question 12. So it's very similar to question 11. So take a second, see if you can figure it out yourself as well. Okay. So using the approach of just finding the difference between the two equations, Fahrenheit of x, so that's Kelvin, right? X is Kelvin. X minus 273.15 times 1.8 plus 32. And now we're saying, what if it increased by 5 Kelvin degrees? So x plus 5 is x plus 5 minus 273.15 times 1.8 plus 32. So what we did is, remember, we just plugged in our x value, right? Even though it looks kind of weird, but we're just saying, like, this is what we're plugging in. We could have easily just wrote down, like, 5 and this 10. Okay? And the goal now would be to actually just expand these out and to see what's the difference between these two equations. So 1.8x minus, just a quick calculator, 273.15 times 1.8, 491.67 plus 32, 1.8x minus 459.67, and our second equation, x plus 5, let's leave that as it is for now, times 1.8 minus 459.67. Again, you should be able to recognize that this is the same as this first equation, and what we're going to see now, this is 1.8x plus 5 times 1.8, which is 9. So all of this comes from the first equation, right? That didn't change. And the only difference is that we add 9. So A, that's the Fahrenheit of a 5 Kelvin increase. Now you could take an example instead. You can try this out. You could say, what's f at 5 equal to? Plug in 5 for x. Then plug in 10 for x. And then whatever the difference is between the two Fahrenheit degrees, so you would do 5 at 10 minus 5 at 5, f at 10 minus f at 5, and then this will also give you 9.